Well, hey, I thought I'd start with this slide. Hello, everyone, as a starting point. I think that's a good way to start. Just want to point out this is not me. This guy is way more confident than I am, but thought I'd start with that. But anyway, so what's the problem here? Because we've got this cool technology that we can ask it to do anything, like ask it to generate a report, and it'll just do it for us. So what's the problem? Here's an indication of the problem. It's at 80% of our projects fail. That's twice the number of projects that don't involve AI. In other words, you go to present that cool, swanky presentation, that report that AI gave you, and you realize it's nothing more than a vacuous shell of content. It's devoid of meaning. It's just hollow. And that leads to reputational damage. So what is this webinar about? In this webinar, I want to explain my strategy for using AI within workflows. I'm going to share with you 3 example workflows in n8n, but actually more important are the techniques rather than the tool itself. And I'm going to highlight some key learnings and techniques along the way as I talk you through those workflows. And then after that, we're going to have some discussion. So, and by the way, if there are any questions along the way, please ask them in the comments. I might answer them as I go along, or I might, wait till the end. We'll just play it by ear. But yeah, please do engage in the chat, and I'll pick up any sort of questions and stuff from there. So, and a word of caution as well. The solution that I'm proposing here is going to involve more work. So it may not fit the mental model that you have or of these sorts of webinars of using AI and things like that. So this approach does require more human involvement, but I think this is the path to the best output. And also it's the greatest protection of our skills. Because my guiding principle with all of this is to have greater control of our work. And it just so happens that this also leads to best quality as well. So let's reverse a little bit and go back to the problem. And so you ask your LLM for a report, and it gives you the report, and most days is good, everything's good. But some days it's not, because every now and again you ask for a report and you get something else. You get something that you didn't ask for. And this is called non-determinism. This is going to be the key central part of the entire webinar, what I'm going to be talking to you about, and the entire strategy is built around adding determinism to non-determinism. But what non-determinism is that it means that we are not guaranteed the same answer each time we use an LLM. And that's just an intrinsic way that language models work. And I'm using LLMs, AI, and language models interchangeably here, so keep that in mind. To explain this a little bit more, I tried this prompt. So this is the simplest prompt that I could think of. It's very simple. And when I ask 2 + 2 and ask multiple models, just 2 + 2. So again, that's the only prompt that I'm setting. These are the responses that I get back. So 2 + 2 = 4, 4, sum of 2 + 2 is 4. So now this might not seem like a big deal, but even though everything gives the same answer, 4, it's the way that they present you the answer is a problem. And it's a problem when you go to scale, and it's a problem when you go to develop production systems. And again, this is just a simple demonstration, that 2 + 2 is just a simple demonstration to illustrate the broader problem. And in that, as you increase the complexity and as you scale up your use of these non-deterministic tools, these LLMs, you increase your non-determinism. So increase complexity of the prompts and your input, you increase the non-determinism. And that variability can mean reliability issues and consistency issues. And again, this is all a matter of scale, which is why for Convert, a lot of the stuff that I've been writing for them, a lot of the content that I've been producing for them is all centered around this sort of concept and different ways of approaching this concept and chipping away at the problem. And if I was to summarize all of this content, it would be through these keywords. And all of these will be touched on throughout the webinar as I go through everything. So keep that in mind. But I'll try and highlight some of these as I go. So on to the 3 workflows. So I'm going to share with you 3 workflows. I'll just give you a brief overview of what these workflows are, and then we'll go straight in. So example 1 workflow is, say, for instance, you want to create a redirect test. So ignore whether or not it's a good idea to do redirect test client side. Just you know, as I said, we want to do a redirect test. So we come up to the LLM and we say, like, oh, we have a redirect test in mind in terms of a change request, and we want to create a regular expression to redirect traffic. Problem is, these tests are very, very risky. So this workflow bakes in basic level of QA. More details on that later. And it doesn't mean that you don't do QA. It just means you reduce friction and the risk. So it's an automated workflow to reduce friction and risk in that when you're creating regular expressions for redirect tests. The second example is, again, an A/B test creation, but this is much more traditional JavaScript code for an A/B test. So you as a human requests a code for an A/B experiment. So you have an A/B experiment in mind that you want to do, and you explain that in just plain language. And then the workflow creates more reliable code using QA built in. So again, it doesn't negate doing a QA as part of the process. It just reduces the friction and reduces the risk a little bit. And the final example, the third example, is going to be a marketing content example. So this is a protection against fake and nonsensical claims. So what this does is, imagine you've got some text, some marketing content that you want to put out. This workflow extracts the claims being made and then does a deep review to validate claims. And then it outputs something like this. And I'll show you a bit more about that as we go. So a word of warning, these workflows can seem complicated, but remember, we're not here for the workflows themselves. We're here for the techniques. And as I go through them, I'll highlight what those techniques are. And again, any sort of questions, if you want me to slow down or go through anything again, just mention it in the comments. Okay, so let's go to the workflows. So the first workflow is that redirect test. So how to look at this? Some things to look out for. One, these are the non-deterministic steps. These are the LLMs. So anything you see that robot head, and when you see that chain link, those are LLM calls or language model calls. And all of these will be using small models, by the way, so no frontier models at all in use here. Everything else are non-deterministic steps. So, deterministic steps. So these are code steps, and these are, browser GET requests and stuff like that. There'll be stuff that I'll gloss over, which are stuff to do with flow, like merge and if statements and stuff like that. I'll ignore those, but just highlight, just keep in mind that anywhere you see these sort of icons, those are LLM calls non-deterministic steps. Everything else are deterministic steps. And then wherever you see weird stuff like this, those are flow stuff. So in terms of the redirect test, I'm going to ignore the trigger because a trigger could be anything. What imagine like the first step, you get you accept a URL from the user, or this workflow accepts a URL from the user and a change request, and also a sitemap. And I'll explain why that's important in a second. So when you send over the change request, that's your plain text explanation. Redirect blog articles to articles with all pages on the blog. So that's the redirect test that you want defined. The first step that happens is it goes and fetches a sitemap. So this is a non-deterministic step, a tool that goes and fetches the sitemap, which is a link of all of your pages on your site. And then it basically just formats them into a list. So all of these things are just like deterministic tools. It's just basically fetching data and converting data. The LLM step just uses all of that information and the URLs to output which URLs are in scope for this redirect test that you want to make. For this change request that you have, which URLs are in scope and which URLs are out of scope. So what you'll notice is that after an LLM call, and you see this a lot as a pattern, after every LLM call, non-deterministic step, there's a deterministic step to either structure, format, or review, validate the output from the LLM to make sure that everything is in order for it to continue to the next step. So what this is doing is it kind of goes through, okay, for every single URL, it says scope false or true, etc. And then after that, it writes a specification document. So again, this is another pattern that you'll see, and this is something that I like to call output first thinking, is where we're already thinking about the output and we're already sort of like wanting to work towards output, and writing a specification document is one of those steps to define what that output might look like. I won't show you this specification document, but I'll show you another one for the other experiment tool. And then only after that does it go through all of that information, goes through to the LLM to write the regular expression. And the technique I'd like for you to focus on here, and you probably can't see it very clearly because there's a barrage of text, but it's called few shot, and this is a way of trying to reduce the non-deterministic nature of an LLM, at least from a formatting perspective, by just sharing some input-output examples. So I've got some input of a change request and output the regular expression and the replacement text, and I've got that multiple times before feeding in my actual request. And then that goes through to, again, non-deterministic step, regular expression, language model, writing the regular expression. And then we've got a validator, which takes the sitemap where we've got a list of all of our URLs to say, with scope is true, is in scope, or it's not out of scope. And it's a deterministic step. It's code-based sort of check that goes through with the regular expression, goes through every single URL. Is it applied? Is it supposed to be applied? And then so it's like a QA against all of this, all of your URLs to make sure that everything is as it should be. And then at this point, if it's there's a point at which it needs to decide whether or not things are good enough to continue or whether or not it needs to try again. So if there's any errors, it'll go back and it'll try again. And then after that, it'll set the experiment name and it'll give the final output, which is regular expression, match and replace, and then the test name, etc. So that's the first one. And this is just a quick sort of thing to say, like, imagine for that the main step of regular expression validator, imagine it's doing this for every single URL. For every single URL is going, this URL, is it applying? What is it changing to? Does it all look okay? Yes, no. And then it goes through to the next one, next one, next one. So that's the redirect test. The next test is the A/B experiment test. And ignore this guy. This is just a way to trigger. So again, I'm going to ignore the trigger for now because you can trigger it in any other ways and different ways. So this is the variables that are being set. So basically the information that's being sent by the user, just mimicking that. This basically has a URL and then a change request of what the A/B experiment should be about. So the A/B experiment is make the smoking bones panel on this page appear first in the list. So that's all that is doing. And then we've got some deterministic steps here. It goes and fetches the HTML for that page. And then here's the content. It just fetches that content from that page. Then same as with the redirect tests, it writes a specification document of a technical specification document. And this is an example of what that looks like. So it basically just reviews, okay, change user has said this, and it can be a little bit vague or whatever. So let's try and nail down what the primary objective is. What are the constraints based on the observations from the DOM? What are some key things from the HTML and from a technical perspective that it needs to focus on? Like, here are the key structural elements and what the visual impact should be looking like. And then strategy for DOM manipulation as well as expected DOM changes. And this is, again, output first thinking, where we kind of like, we want to put forward, like, okay, what is the end state of that page? What is that end state supposed to look like in terms of the HTML of that page based on all of the information that it's got? So, and that's that technical specification document. And then it writes the QA rules. Like if you were a QA, what would you check? And this is done in plain text language as well. So when you review this, it's just plain text. You'll just say, I'd want to check this and I'd want to check that based on what's being manipulated, based on the specification document, and based on the tech stack of your site and any other domain specific knowledge. And then only then, after all of that, does it write the main JavaScript. So again, keep in mind that when you're using Claude Code or something like that, all of these steps are still happening, but you have zero control over them. And sometimes it will do those steps, and sometimes it will not do those steps. And there's no consistency, and sometimes you'll just fake it. What this is doing is we're just kind of like putting it into a workflow where each and every single step is an absolute requirement. So it's not even a question of whether or not it can use this or can do this if it wants to. Every single step needs to be done in order to work towards a final output. And again, we've got the right JavaScript, and then this just extracts the JavaScript and just validates that this is in fact JavaScript. And then using the QA rules and using the JavaScript, it writes JavaScript-based tests. And again, this is why in that tech spec document, the DOM changes, the expected DOM changes are so important, because it's going to be writing some rules, some deterministic sort of set of rules to validate whether or not the changes that the JavaScript, that the LLM has created the JavaScript for, does it apply accurately? And so this just basically, creates a JavaScript for the tests. And then this is just a step to make sure that if it's if the JavaScript is sent over to browserQL, which is the tool that I'm using to render the page to mimic a user browsing the page, is going to a tool called Browserless, and browserQL is the language that it uses in order to do stuff and automate stuff on that side. So what this is doing is just kind of make sure that everything is correct to send that data through and make that request. So then it runs that test, and then this just evaluates a test. So like, okay, what were the results of that test? What did it fail on? Why did it fail? And if it did fail, it'll go back to the start and try again, using those failure messages to try and correct those failures. And so this is like what it's doing, what went wrong, and then there's a JavaScript fixer. And again, there's like a deterministic step just to check that everything's output correctly. And then on the output, you get a log of the tests. And, these are the tests that it ran and what happened. This is a JavaScript, obviously, to put into your testing tool. And this is the specification document. And you could also output the QA rules as well. So all of this can go to the relevant people, QA rules, so the QAs know what they need to test, and if they need to add anything extra and stuff like that. So that's the second example. Again, ignore the fact that it's a workflow and all of these kind of, it looks quite complicated and stuff. The techniques are the main thing that I want to drill down to you. The next one is the sources. So the marketing content. This one looks quite complicated, but I'll take you through bit by bit. You can ignore most of these things because most of these things can be API endpoints. But again, just as a reminder, what it's doing is it takes some text, some raw text, and then it basically extracts claims made from that test. I've got a duplicate here, but never mind. It extracts claims from that text and then finds a source, finds the primary source, the link to the primary source, and then whether it's been validated and an explanation. And the false isn't, I need to change this. False isn't necessarily that that it's a invalidated claim. It's just that it wasn't able to validate it. So it just needs human intervention if you want to keep that claim. But otherwise that's how it works. And then in here, I have a list of sources that I trust. So these are all a list of sources, and you can have a bunch of other sources, like you can manage your own sources as well with that. I recommend doing that. So what this, how this happened, what happens here, again, ignore the webhook. So you got this text. This is some text that I've kind of transcribed. And then the first step goes through to extract claims, and it just kind of extracts the claims, first lists the claims, and then cleans up the claims before splitting and exporting the claims. Again, it's kind of breaking things into smaller steps. And then this kind of is a gateway to using smaller models instead of using these large frontier models, and also makes everything a lot more reliable. This is just a loop. Ignore that. So it searches for a claim. So just a web search for a claim, and all that is just searches the web and fetches the results of that. And then it goes through the claim accuracy check. And in the claim accuracy check, the first thing that I'm done, so I've tried to do as many deterministic steps here as possible. And the first deterministic step here is to check, hey, are any numbers in this document? Are any numbers in this claim? If yes, check whether or not the numbers exist in the resulting in the search text. If it doesn't exist, if that number doesn't exist, well then it's it's invalidated. So then it just returns false. And again, doesn't mean that it's not validated. It just means that you need to manually go and find that. The next technique is this is basically the same prompt asked 3 times. And what this does is it takes that claim text, checks it against the source text from the search, and then says, are these saying the same thing? Is the claim accurate to the text, to the source text? And then that answers 3 times, and then all 3 have to agree in order for it to continue. Now, ideally, if this is just like an something that I built in n8n, but ideally, I would use many more deterministic steps here, as I've done for my tool Resada, which basically does much more deterministic style validations as well. So it's not sort of like a wedded to, doing things like, because I call this a hack of like asking the LLM 3 times and then seeing if all of them agree. So we're not sort of like so wedded to one specific way, but loads of different sort of deterministic steps in order to know whether or not claim text and search text is actually, in this has a high degree of similarity. So then the check accuracy. So this is that claim check accuracy comes back. It extracts the source if it's true, if it's gone through that first hurdle of everything's valid so far. It extracts the source. Who is the source for that claim? And then it goes through to a final validation claim, which finally does a deeper investigation to that source to validate that. And again, notice that all of these are deterministic steps. So it does a deep search in terms of it searches that text, the actual page. It or gets a list of that source and then lists everything in terms of the order of trusted domains. So all of the trusted domains are floated to the top. Again, deterministic step. Fetches a content, checks if the content is garbled or if it's like a proper context, and then it does a claim check accuracy against that. So it just runs this thing again, and then after that it outputs everything to the document, which is what you see here. So then you'll say this is true, and if it's true, explanation as to why. If it's false, explanation as to why. So for instance, for that 42% that I said in that transcript, it wasn't 42%, it was 43%. So at least this explanation gives me some clue as to go through and do some deeper dives into that. So so those are the workflows, and those are the techniques. Just want to open the floor to now the discussions, questions, and then I can go through them.
I'm curious, Iqbal, it's a lot of additional work to create those workflows. And we've been also told to just hand the agent a goal and step back. What made you go the other way?
It's accuracy, because when you do things through Visual Studio Cursor, or no, not Cursor, uh, Claude Code or ChatGPT or whatever, um, inside under the hood, it's actually doing the step, but it's doing it in an agentic way, in that it gets to decide if and when to do a specific step. And all of these steps, in my mind, are absolute, you need to do each and every single one of the steps. It's a given that each step needs to be done in order to work towards the output. And so by controlling the workflow, I'm able to control, for instance, the depth at which it goes to research the claims, for instance, that are being made here, or to make sure that it's done on automated tests, and then I can get visibility of that automated test that's ran, a visibility of the checks that it's ran, and an explanation as to why it's passed some and not passed the others. Whereas if it's all happening within a black box, you completely lose control over what's happening. So it's a way to add uh, again, like determinism at a much broader scale to the workflow itself. So I know it's a lot more work, but I think to be to be generous about it, I think we've been missold the capabilities of a lot of these tools. And even if the tools do work sometimes, they don't work all of the times. Again, the deterministic aspect. And if it doesn't work all of the time, well, then it's a problem some of the time. And you don't know when it's a problem. And that, going back to the reputational damage thing, you're giving up control, and you're giving up your reputation to something that is a black box.
Thank you so much. And do you think, or when do you think it's worth creating the workflow versus just winging it with the chat interface? Are there any cases where you would suggest going with the chat specifically?
Yeah, I mean, if you're doing things, a one-off task, if it's a task that you're not going to do regularly, it's just like, you're just doing this task one-off. And if you are overseeing that task, and if you're able to drill down manually and make sure that, hey, LLM, have you thought about this? Have you thought about that? And stuff like that. If you're in full control of that interaction, then I think is fine. Just use the chat. But if it's at all something that you want to be doing on a regular basis, if it's something that your company does on a regular basis, then you want to have some sort of some guardrails around how those tasks are done, and you don't want to really leave it to a black box to figure things out, especially when not everybody in your team are going to be drilling further in the right ways. So whenever you're doing tasks on a regular basis, I'd say, put that down as a task that is ripe for automation, which is effectively what all of this is.
Thank you so much. We have a question from Craig.
Mm.
In the experiment 2 example, how do you handle differences in how tools handle regex? Are there any major differences in those?
When to handle regex, what do you mean?
Yeah, the differences into how different tools handle regex.
Oh, yeah. So I think this would come down to your writing the regular expression. So this is the few shot example. So in here, as you see, there's a lot of uh, input output examples. And so over time, you probably build up a catalog of, redirect tests that you've done in the past or whatever. You need to feed all of that in as rules, to say, like, these are the ways that this is the format of that my tool wants to get the regular expression at. So again, it's like few shots just kind of trains the attention of the model to return the regular expression in a specific way. So there's no real easy, I mean, you can do something like I'm using this tool, I'm using JavaScript. There's some shortcut tools that you can, or some verbal commands that you can use to train that attention. But then overall, the best is doing these input output examples. So input, URL, change request, output is the kind of like regular expression that I want back. And once you do that a few times, then you get everything back in a reliable, sort of consistent way. Did that answer that question?
Yeah, indeed. And one more question about determinism. Well, there are some things which are tough to make deterministic, like, for example, language-based summaries. How do you add determinism here?
So I thought that as well. Like, hey, there's some things that like language-based stuff, that's difficult. That's nigh on impossible to add determinism to that. I've been working a lot on that for my Resada app, which just does extracts insights and summarizes text like at a large scale. And I found a whole suite of techniques that I can use to add determinism. For instance, before summarizing, like getting the text, you can use natural language processing sort of techniques to, for instance, extract entities, relationships, attributes from text. So, for instance, if you have the sentence, Steve Jobs slipped on a banana peel, hit his head on a Windows computer. So the entities there, Steve Jobs, banana peel, and Windows computer, those are entities, those are things. The relationship, well, Steve Jobs slipped on the banana peel, so that's a relationship. And then Steve Jobs hit his head on the Windows computer, which is a relationship. And attributes are kind of like, if things that he said he hit his head very hard or whatever, those are attributes. So there are deterministic tools that can extract entities, and then using those entities, you can then use another set of tools to basically check say you want to check that summarization has been done correctly. You might want to check whether or not all of the entities are there, or all of the relationships between the entities are there, or the key entities that you're focused on are there. The other things you can do is you can check the similarity between texts, and you can do that deterministically as well, because you can use a tool that embeds the text in terms of an embedding in terms of numbers. And then when it has two sets of numbers for two sets of text, it can just do a diff in terms of see how semantically similar are these texts. So now again, this is me. If I go back to this guy here, this is why I've got these things separated as separate steps, because there's certain limits that you can get to when you're using n8n, but obviously beyond that, you're wanting to do stuff beyond the scope of n8n, which is why I say this is not about n8n. This is about the techniques and the tools and the sort of approaches. So these sort of tools that I'm talking about, like embedding, and it sounds very technical and it sounds very difficult, but there are ready-made modules, Python modules, script modules that automatically do this for you. Just send it through to a variable, send the items to a variable, and it returns that to you. So as soon as you have loads of different deterministic sort of checks on some text, you can start to put together an index of, say, this check passed on this number, these are the results of these checks. And then now you've got a really good deterministic framework in order to decide whether or not an LLM output is accurate or not. And the best thing about all of this is all of these deterministic tests happen more or less instantaneously, because this is code that we've been using for decades, and like iterating through every single URL and validating it against regular expression and checking if it passes or not. That happens microseconds, much faster than if you were to send a request to LLM and wait for a response. So yeah, I would say, like, long story short, there's a lot of ways that you can add determinism. It just needs a little bit of a research, including stuff that seems very difficult, like, when you're dealing with text and language.
That's smart. Thanks so much, Iqbal. We have some questions from Andy. How do you decide which model to use at each step? Like, that's the first one. And then the second would be, I also noticed some of the LLM steps. There is a memory step linked to it. What's the need for that, and how does it work?
So I'll tackle the memory thing first. It's basically, here we go. No, I know. It's basically wherever these are agents. Agent means it's going to try any number of times until it's delivered something to the structured output, which is this. So this is the structured output that it needs to output. The memory is how many times it tried. So whenever it tries first time, tries to deal with a structured output, and imagine like you've got multiple tools in there as well. So if it's you'll try for the tool, and then the agent decides, oh yeah, as my task here, my goal here is to, for instance, do the math. 2 + 2 = 4. I'm going to use a calculator. This is my tool, and it's going to come back, and then this regular expression say, well, did that come back with a number? Yes. Okay, great. If it didn't come back with a number, then store that in memory to say, okay, what happened, and then send it back to the tool. So basically, it's a memory of how many times the tool iterated in order to, or the agent iterated in order to get to the step. So every single tool will store things into memory, and then if it needs to use multiple tools, it'll use a memory to use a multiple tool. So it's basically like an n8n thing to give it some built-in memory. So the other thing, how to pick the models. I'm doing it. It's going to sound like I'm plugging something, but I'm doing a lightning workshop soon with the TLC group, where I go into small model selection in much more detail. But short answer is that I always go with the smallest model first. And then, like, there's some specific go-tos that I have for coding. So for regex, for instance, it'll be the Qwen3 coder next. And it's a very small model. It's open. It's open weight, which is also important to me. And also it gives me the answer consistently and reliably for that. So I just do a round of testing. So I have a Qwen3 coder next, which is my go-to coding model. But failing that, there are some other models as well that are some backup models. If Qwen3 coder next, for whatever reason, is not good with this step, I'd go to the Mistral CodeStrol small model, or try some of these other small models before going up the model ladder to picking something like a GLM, which is equivalent to the Claude Sonnet, which is as good as Claude Sonnet, but like a fraction of the cost. And also you've got the Kimi K3 as well, which is also doing the rounds that everybody's shouting about. So yeah, I have a list of go-to models, and then I have a smallest model going up, up, up until going to larger ones. I've never needed to go to the larger ones. Qwen 3 Coder Next or similar seems to do everything fine. I also like to pick models that I know are open. So then, while all of these models that I'm showing you here are based on the cloud, so they're just accessing those models on the cloud. If I needed to, I could run them locally. So that's another choice factor that comes into it. Is it an open weight model? Is it available for me to run locally if I need to, if it suddenly becomes not available anywhere else and I need this model? But yeah, you sort of like start to pick your go-to models as you do some investigation, as you investigate small models. Gemma 4, by the way, is a very good model for just plain language stuff. So Gemma 4, Qwen 3 Coder Next, those are kind of like baseline coding language, and then go develop from there. But yeah, I'm doing a lightning workshop where I go into all of this in much more detail. So yeah, it'll be on the TLC channel with Kelly.
Right. Some pretty good insights. And before we move on, Iqbal, we have two quick questions. Well, Daphne has built a Claude skills with built-in evaluation. So now the question is, are you seeing this isn't following those steps consistently? Or is it more that you don't have control over those steps?
No, if you're building, so good, very good question, and a really good point. So again, like this is I'm showing you this in n8n because it's very visual way of showing you like these techniques. And so these techniques are, you can see very clearly how these techniques work. You can use the same techniques in lots of different ways. If you, in that example where you have evaluation from Claude Code, you can have Claude Code generate some script for a very specific workflow, and depending on how detailed you go into it, you can have it either to evaluate certain steps, or you can have it build something like this workflow, but in a code sort of format. And then Claude Code will have access to that workflow, to that code-based workflow when you ask it that specific question. So when it knows that you're asking a regular expression style question, it may know that, okay, I need to use this script file or this skill, which then accesses these set of scripts on my local machine. So then it's kind of like a halfway step between moving away from the flagship models and going completely open to kind of like a little bit in between. So it reduces your token costs because it's going to use that workflow each time, the script-based workflow each time, but it keeps that token cost in quite a high level because it's using Claude Sonnet for every single one of those steps. But yeah, there's bear in mind that this is all a visual representation of the workflows and the techniques. This can be in script form that you can run from any number of sources. But really good question. Thanks for that.
And in simple terms, Iqbal, I'm curious, what is open weight? I think there is some confusion around it.
Yeah. So when it comes to models, you have all of these parameters that you can pull, all the levers that you can pull in order to determine the output of your LLM. And all open weight means is that you can influence the weighting of that model, the way that the model outputs something by doing fine tuning or whatever. but it's not full open source, i.e., you don't know how it's being trained, you don't know the intricacies of the details of it, but it's open weight in as much as like you can influence the behavior of the model. And you can, and because it's an open weight architecture. That's like just very, very sort of simple nutshell.
Thanks for that. All right, I think these were most of the questions. I have one kind of last question. How do you go about creating a customized workflow based on a task? Or how do you break down a task into a workflow?
So if you think that you do that by following, there's like a work breakdown structure, like the project management sort of process. And so you can take a project and you can use a work breakdown structure to break down into steps. And then you can, once you have a good understanding of determinism and non-determinism, what deterministic tools, when to use deterministic tools, what deterministic tools are available, and you know when to go for LLMs versus when to go for a deterministic tool, then you can start to put together a workflow. I've also got, if I zoom to the end, a workshop. I'm doing a workshop on Thursday, 24th of September, which is to go through that exactly. And what this workshop is going to be doing is taking you through the basics of understanding LLMs, so you know what LLMs are good for, when to reach for LLMs. Deterministic tools, just highlight when to understand how to increase the vocabulary of deterministic tools, how to do that breakdown, and then how to take all of those principles and apply them to n8n and go through some n8n basics in the afternoon. So it's a very highly involved, like heads down sort of 1 day workshop. But yeah, I'll take you through the full sort of flow. But like, you know, that in a nutshell, work breakdown is what you need to be doing. I don't know, Craig, Jackie, if you want to say something about this.
You said everything, Iqbal. Thank you. Thanks for this, by the way. It's been brilliant. And thanks to Convert for organising too. But you said everything there. And I've put a link into the chat where people can go and see more about the workshop. There is a QR code on the slide, but you can see it from the link, go to it from the link. So it's a full-day workshop on the 24th of September.
And it's in person as well.
In person.
Yeah.
Yeah. We've already held a workshop with you recently before Space Academy, and the feedback's been brilliant on this. So we're really looking forward to doing this with you again, Iqbal.
Thank you.
Yeah. Anything else to add, Craig?
No, definitely not. No. Iqbal and you've just covered it all. But I just wanted to say thanks to Iqbal and thanks to Vlad and Convert for doing this. This has been very good. Thank you.
So one other thing is like those workflows are available if you go to Convert's blog. I've got a lot of write-ups on those. You can download those workflows and then just play around with them, but use them as a baseline to, you know, develop your own workflows. But I've got some other sort of articles as well, which are probably going to help fill in some of the other sort of questions and stuff that you might have. But yeah. But any of the questions, just reach out and ask me direct. Cool. Hello.
Cool. Well, thanks, Iqbal, for all the valuable info, as well as presenting the workshop. It will be super fun. I would encourage everyone to take a quick look. And yeah, with that said, any last words, Iqbal, before we close off?
Oh yeah, one last word. Let me get there. Don't trust big tech. This guy, Dario Amodei. Everybody is holding up as the angelic of the big tech guys. But he, like open source is a dangerous path, as he's saying, is trying to close down open source and open weight models and stuff like that, get them into control. You really don't need big tech models to do any of this stuff. In fact, you're better off using smaller models and you get better output if you just think in those sort of terms and break down your task and take control, take ownership of the of your own workflows. So yeah, that's all I'd say to end with.
Thanks, everyone. And with that said, looking forward to seeing you at one of our next events. And yeah, thanks, Craig, Jackie, and Iqbal as well. See you soon.
All right. Thank you. See you soon.
Goodbye, everyone.
Thank you.